Hi! Welcome to another lecture video of Math 21. In this video, we will discuss volumes of solids of revolution by washers and volumes of solids by slicing. We will split the lecture into two parts. For the first video, we will talk about volumes of solids of revolution by washers. For the second video, we will have volumes of solids by slicing. Let's begin! What is a solid of revolution? A solid of revolution is a solid obtained when you revolve a plane region about a line in the same plane. This line is called the axis of revolution. Note that we will only use axis of revolution that is either vertical or horizontal. Here is an example of a solid of revolution. Consider the plane region bounded by x equals y squared here and y equals x squared here. Okay? So this is a plane region. Revolving this about the x-axis will give us this solid. So this is an example of a solid of revolution. Another example is, let's say you have this plane region that is bounded by the graph of y equals sine x and the x-axis on the interval 0 to pi. Revolving this about the y-axis will give us this solid. So this is another example of a solid of revolution. Now, there are two methods to find the volume of a solid of revolution. First, we have the disk or washer method. The second is cylindrical shell method. For both methods, we divide the region into rectangles, but the difference is in the type of rectangle. For disk or washer method, we use rectangles that are perpendicular to the axis of revolution, while for cylindrical shell method, we use rectangles that are parallel to the axis of revolution. For this video, we will only talk about disk or washer method. If you are interested to learn about the cylindrical shell method, then you may read about it in the Math 21 module. So, let us now discuss the disk or washer method. First, we divide the region and orient the rectangles so that they are perpendicular to the axis of revolution. So for example, in this case, our axis of revolution is the y-axis, here. Okay? And we know that the y-axis is vertical. Therefore, we will use rectangles that are perpendicular to the axis of revolution. In other words, we will use rectangles that are horizontal. So we will divide the plane region into horizontal rectangles like this. Now, if we revolve the plane region about the y-axis, we will obtain this solid. So, in particular, a part of the plane region, which is this red rectangle, is, well, if we revolve that as well about the axis of revolution, then this will also give us a solid, but this solid will now look like this red object. And this is called a disk. For another example, consider this plane region where the axis of revolution is the x-axis. Then, imagine that this red line is a rectangle. If we revolve the rectangle about the x-axis, we will obtain this red solid, and this one is called a washer. Let us show a picture that will show the difference between a disk and a washer. Notice that a disk is simply a thin, right circular cylinder. Meanwhile, a washer is a disk but with a hole in the middle. So that's a basic difference between a disk and a washer. Notice that there are rectangles here in the picture. This shows that the disk and the washer can be formed by revolving those rectangles about the axis of revolution, similar to what we have done in our previous pictures. So our question now is, Is there an easy way to know if we will have a disk or a washer whenever we have these rectangles? The answer is yes, there's a way, and it's actually easy. All you need to do is check the boundaries of your plane region. You have to check if the boundaries of your plane region has a segment that coincides with the axis of revolution. For example, in this case, this vertical segment here is a boundary of our plane region, and it coincides with the axis of revolution. So therefore, this rectangle here, if you revolve, you will obtain a disk because there is no way that you will obtain a hole in the middle. Okay? So, disks are formed if a boundary of the plane region has a segment that coincides with the axis of revolution. Meanwhile, why do we get a washer in the next example? This is because none of the curves here, or none of the boundary curves of the region, has a segment that coincides with the axis of revolution. That's why every time you will make an arbitrary vertical rectangle and revolve that about your axis of revolution, you will always find a hole in the middle, and that will give you a washer and not a disk. So washers are obtained when none of the boundary curves of the region has a segment that coincides with the axis of revolution. So let's go to the simple case where we only obtain disks. Our problem is to find the volume of the solid generated when the region below is revolved about the x-axis, or that is y equals 0. Remember that we are going to use the disk or washer method, and therefore we will be using rectangles that are perpendicular to the axis of revolution. This axis of revolution is horizontal, so therefore our rectangles must be vertical. Let us now proceed with finding the volume. Long story short, what we want to do is the following. First, given this plane region here, bounded by these curves, okay, we want to divide the region into n rectangles. And then remember that this plane region will be revolved about the axis to form the solid, okay? Which means that each rectangle here will also be revolved about the axis, and that will form a solid. What kind of solid will each rectangle give us? So, remember that it will give us a disk, right? Because this boundary has a segment that coincides with the axis of revolution. So each rectangle here will correspond to a disk once you revolve the rectangle about the axis of revolution. Again, we want to find the volume. So, to find the volume of the solid, we first want an approximate for the volume. What will that approximate be? Remember that each rectangle corresponds to a disk. So, if you get the volume of each disk and add all of them, then that will be an approximate for the actual volume of the solid. Then after that, you just make the approximate better and better. So, how do we write this mathematically? First, we divide our interval AB into n subintervals of equal length delta x, here. Then, we will choose an arbitrary point in the ith subinterval. Let's say this is the ith subinterval, and we will choose an arbitrary point. Let's call this xi star. Once you have this arbitrary xi star, we will get the y-coordinate associated to this x value. Meaning, hahanapin lang natin kung saan siya tatama doon sa curve na y equals f of x. In other words, what is that y-coordinate? That is your f of xi star. Okay? So once you have that, what will you be able to form? Then, this will form a vertical rectangle, where the length of the rectangle is the distance from this point to this point, and the width of the rectangle is exactly delta x. And then, remember our story from before? Because your vertical rectangle will be revolved about the axis, which is the x-axis, then you will form a disk, meaning this rectangle here will correspond to a disk. Question now is, what is the volume of that disk? To help us, let's show a picture of a disk. So remember, a disk is just a right circular cylinder. So the volume of a disk is just pi r squared times height. If you look at the rectangle, can you identify the radius and height of the disk formed by the rectangle? So if you imagine revolve, you get the disk, right? So this distance here will be the radius of the disk. But this is a vertical distance. So how do you get the vertical distance? Remember your lesson on areas? The vertical distance is measured as the distance or the difference of the y-coordinate on top minus the y-coordinate at the bottom, or y up minus y down. So the y-coordinate on top is f of xi star, while the y-coordinate at the bottom is y equals 0. So the radius will be the difference of those y-coordinates, or radius is just f of xi star minus 0. Okay. How about the height of the disk? The height of the disk is simply this delta x. Okay. So, what is now the volume of this particular disk? The volume will just be given by pi ri squared hi, and using these values, we can replace it with this expression. So, remember our story from before? Each rectangle corresponds to a disk, and what is the approximate of the volume of the solid? You just add the volumes of all the disks. But how many disks do we have? There are n subintervals, so there will be n rectangles. And since there are n rectangles, therefore there are n disks. Okay? So we add all the volumes of these n disks, and that is just an approximate of the actual volume of the solid. So the actual volume of the solid is approximately equal to the sum of the volumes of the n disks. And Vi here can be replaced with this expression from what we have obtained from before here. Okay? So, question now is, how do we make the approximate better? The approximation could be better if we have more rectangles, right? So, meaning if we increase the number of rectangles, we will make the approximate better and better. Okay? So, how do we get more rectangles? That means that we should have more subintervals. Okay? And that means we should increase the number n. Okay? So if we increase n, there will be more subintervals and there will be more rectangles. And more rectangles means what will happen to the delta x. Then, delta x here will become smaller and smaller. So the widths of the rectangles will be smaller and smaller. Meaning, with more rectangles, we will have thinner rectangles. Now, each rectangle corresponds to a disk. So, more rectangles means more disks, but these disks will now be very thin. Okay? So, imagine there are many thin disks, And that will give us a better and better approximate of the volume of the solid as we increase the number of those thin disks. So in other words, to get the actual volume, we will just let n go to infinity, okay? So that we will have infinitely many disks that are very, very thin. Therefore, we obtain the actual volume of the solid. So, we let n go to infinity, okay? And mathematically, we just write it in this way. So, we take the limit as n approaches infinity of the approximate of the volume, okay? And this right-hand side will be equal to the actual volume of the solid. That's why here we get an equal sign as opposed to the approximately equal sign from before. So, because this is already the actual volume. Okay? And remember our lesson from areas. So, this can be written as the definite integral from a to b. And we can now remove the subscript I and the star. Okay? So, we will now have this one. And delta x will be dx. Okay? So, this is now our formula for the volume using disks. But remember that this is the case when we have vertical rectangles. In a similar manner, if we have horizontal rectangles and our axis is vertical, so if we have something like that, then we will still have a similar process. But instead of delta x and dx, what do you think will we have? So this time, instead of x-axis ang hinahati natin, ang hinahati na natin ay yung y-axis. And therefore, we will have delta y. That means delta y na yung thickness of the disk. So instead of dx, we will just have dy. And of course, that means the integral or the definite integral here will be dy. So everything will be in terms of y, including the interval here. Okay? So that will be the counterpart when you have horizontal rectangles. So, in general, if disks are obtained, meaning one of the boundary curves has a segment that lies on the axis of revolution, then volume will be just this formula. Okay? So it's a definite integral from a to b of pi r squared dw, where here, AB is the interval covered by the region, r is the distance of the farther tip of an arbitrary rectangle to the axis of revolution, just as you can see here in the picture on the left. Okay. And dw is the width of an arbitrary rectangle, or in other words, it's just the thickness of the disk. So, of course, we know that dw can be either dx or dy depending on what type of rectangle you're going to use. So if you're going to use vertical rectangles, then that means ang hinahati nyo ay x-axis, meaning you will have disks whose thickness is delta x, and that's why you will use dx. Therefore, dahil ginamit na natin yung x dito, and definite integrals should only be expressed in terms of one variable, then that means we must set up the entire integral in terms of x, meaning yung radius is in terms of x and as well as the interval. The interval should be in the x-axis as well. Okay? So meanwhile, if horizontal rectangles naman are used, then use the variable y. Okay? So everything here in terms of y, including the interval which will be in the y-axis. And if you need help in setting up R, then just recall the lesson from areas that so if you have vertical rectangles, then you must use vertical distance, which is just change in y coordinates. Okay? And this is written in terms of x. Okay? So y in terms of x. So that's why the whole expression here will be in terms of x. So meanwhile, if you use horizontal rectangles, then that will make use of horizontal distance, which is just change in x coordinates. And this is now written in terms of y. So here, x in terms of y sila, kaya the entire expression here will be in terms of y. Okay? So, also, just recall that this is y up minus y down, meaning yung y coordinate muna ng taas minus y coordinate ng baba. And this is x right minus x left, meaning x coordinate ng nasa kanan minus x coordinate ng nasa kaliwa. Okay? So those are our tips, and let's try to apply them in our example. So, consider this region bounded by y equals x squared, this parabola, y equals 0, which is the x-axis, and x equals 2, this vertical line. Find the volume of the solid when r is revolved about the x-axis. So, this is our axis of revolution. So, first, what method are we going to use? We're going to use discs or washers. So that means what kind of rectangles should we use? So since dapat yung rectangles are perpendicular to the axis and the axis is horizontal, so therefore the rectangle must be vertical. Okay? So next question, do we get discs or washers? So in this case, we just need to check the boundaries. Okay? So note that this boundary has a segment that coincides with the axis of revolution. So therefore, we will get discs. Okay? So that means if we draw any arbitrary vertical rectangle in this region and revolve the rectangle, we will surely get a disc because there will be no hole in the middle. Okay? So now, since we will use discs, let's recall the formula for discs. So it's the integral of pi r squared dw. So question now is, what is your variable? Will it be x or y? So remember our tip, if vertical rectangle, then variable is x. Okay, so set up in terms of x. Okay, so that means including our interval, right? So the interval should be in the x-axis. Okay, so here, the interval covered by the region is from x equals 0 until x equals 2. So we get this one. And then next, remember the formula, we need the radius of the disc. So radius is just distance from the farther end of your rectangle going to the axis here. But this is vertical distance, so it's y up minus y down. So what is your y coordinate on top? That's x squared. Y down is y equals 0. So r is y up x squared minus y down 0. So x squared minus 0. And plugging in our all of these into our formula for volume. So we'll have integral from 0 to 2 of pi r squared. So r squared will be x to the 4 times dw, but dw is dx. Okay, so because in terms of x. Now, our question is find the volume. So we are not yet done. We still have to find the exact value where this is equal to. And what is that value? So all you need to do is apply your previous lessons on definite integral. So anti-differentiate this like normal and evaluate, and you get the answer. So this is the volume of the solid of revolution. Okay? So let's go to the next example. So we use the same region, but this time we have a vertical axis. So again, we use the method of discs or washers. So question, since we have vertical axis, our rectangle must be horizontal, okay, because perpendicular. So next, our question is, do we get discs or washers? So notice that this boundary has a segment that coincides with the axis of revolution. That means we have discs. So since we have discs, our next question is, do we use the variable x or variable y? So since this is horizontal rectangle, we have variable y. Okay. So variable y means our interval is from y equals 0 until y equals 4. Okay. And next, what about our radius? Because we use disks, what is the radius of the disk? It will be from the farther end of the rectangle going to the axis, which is this one. Okay? But this is horizontal distance, so it's x right minus x left. So what is the x-coordinate nung kanan? This is x equals 2. X-coordinate ng kaliwa, this is x equals square root of y. So then we will have r equals 2 minus square root of y. So this is x right minus x left. Okay? So plug it in our formula. We have volume is integral from 0 to 4 of pi r squared times, so dw will be dy. Okay? Again, find the volume. So we must find the answer to this definite integral. So before you anti-differentiate, you expand first. Then you can bring pi out of the integral because it's a constant. And then integrate each one individually. And then make sure that pi is multiplied to the sum by writing parentheses. Then once you have this, you can now evaluate from 0 to 4 and you get this answer. So this is the volume of the solid of revolution. So, and yeah, that's it for disks. So, now our question is, what about washers? So remember, washers are obtained if none of the boundary curves has a segment that coincides with the axis of revolution. Okay? So that's why nagkakaroon tayo ng butas sa gitna. And that's what we call, this solid is called the washer. Okay? So, let's now ask, what is the volume of a washer? Okay? So, to help us, let's show this additional picture of a washer. There. So, let's call R2 the outer radius and R1 the inner radius of the washer. So, if it's not, so I think it's clearer if you look at the blue washer here. Okay, so here there are labels. The outer radius is the distance from the center of the washer going to the farther end, while the inner radius is from the center of the washer going to the nearer end of the washer. Okay? So, how do we get the volume of the washer? So, actually, it's just the difference of two volumes. Okay? It's the volume of the bigger disk, It's the volume of the bigger disk minus the volume of the smaller disk. The bigger disk is the one with radius R2, while the smaller disk is the one with radius R1. Okay? So this difference gives us the volume of the washer. So we can write this as this one. Now we can follow exactly the same story that we said before for the method of disks. So this will also apply for the method of washers. So remember the story? First, we divide the region into rectangles. Each rectangle before, diba, we said before that it will form a disk. But now instead of a disk, it will form a washer. So we will then add the volumes of the washers, and that will give you an approximate for the actual volume of the solid. And then we can make the approximate better and better by making n bigger and bigger, or making the number of washers larger and larger. So more washers, making the washers thinner and thinner. And then we let n go to infinity so that you will get the definite integral. So, same story, and then we will get this volume. So the volume is just the definite integral of this expression. Notice that this is the volume of a washer. So instead of before, we have pi r squared dw, which is essentially the volume of a disk. So now we are just replaced by, from volume of a disk, naging volume lang siya of a washer. Okay? So, where here, yung height of the washer is just your dw. Okay? So notice here in the blue washer, it's just the height of the disk is dw. Okay? So other details, AB is again the interval covered by the region, and R2, if you look at the blue washer here, it's clearer. Okay? R2 is just the distance from the axis going to the farther end of the rectangle. Okay? And R1 is distance from axis going to the nearer end of the rectangle. And dw is just the width of an arbitrary rectangle, or in other words, as we said before, it's the thickness of the washer. Okay? So again, we just follow the same tips, but this time it's just a different formula because now we have the formula for a washer. So let's have an example. How do we use the method of disks or washers here? So again, if the axis is horizontal, then we must use rectangles that are perpendicular. So meaning, rectangle must be vertical. Okay? Next, do we get a disk or a washer in this case? So just take note of the boundaries. Since the boundaries do not have segments that coincide with the axis of revolution. So notice the only thing that coincides here is a point, and the point is not enough. It has to be a segment, okay, for it to be relevant. Okay, so therefore, since there are no segments that coincide with your axis of revolution, then we will form a washer and not a disk. Okay, so washers. So since we will use washers, just remember the formula for washer. And now question is, do we use the variable x or y? Since vertical, then we use x. Okay? So what is our interval? Interval therefore is from x equals 0 until x equals 2. Okay? And then next, since we will use washers, remember the formula for washers, we need outer radius and inner radius. So what is the outer radius? The outer radius is distance from axis going to the farther end of the rectangle. So this is vertical distance, so therefore that will just be y up minus y down, where y up is, what's the y coordinate here? It's y equals 4. Okay? So we will have 4 minus y down, which is y equals 0. So 4 minus 0. How about the inner radius? So inner radius is from axis going to the nearer end of the rectangle. So this point. Okay? So what is this vertical distance? So again, y up is 4, and then minus y down. So this now is x squared. Okay? So because it belongs to this graph. Okay? So it's 4 minus x squared. And plug it in to our formula for volume. So volume is integral from 0 to 2 of pi. So R2 squared is 4 squared minus R1 squared, this is 1, times dx. So, and so some things you have to be careful in setting up your volume for washers. Make sure that you write the squares correctly where they should be. Some students write it outside the bracket, so that's wrong. Okay, so you must write the square directly next to your R1 and your R2 and R1. So it has to be directly beside R1 and R2. Okay? And also mind your grouping symbols. So for example, here pi must be multiplied to the entire sum or the entire difference. That's why we have here brackets. Okay? And also, if R1 and R2 are sums, then before you square, there must be parentheses. Okay? Yeah, so just things that you should be careful about. So again, find the volume, which means you have to expand, integrate, and evaluate, and you get this answer. And that's the volume of the solid. Okay? So let's now go to different axis but same region. So Again, what are we going to use? So since the axis is vertical, then so this time the axis is the y-axis. Okay, so this. Okay. So since vertical yung axis, then the rectangle is horizontal. And do we use disc? Do we have disc or washer? Again, there are no segments in the boundary that coincide with the axis of revolution. Therefore, we have washer. So do we use the variable x or y? So this is horizontal, so it's y. So we use y, and this is interval from y equals 0 until y equals 4. So let's write that directly. And now, what are the outer and inner radius? So we have pi. It's outer radius. It is distance from axis going to the farther end. But this is now horizontal distance. So that is change in x coordinates. So ano yung x right minus x left? So x right will be, this one is x equals 2, right? So this is x right is x equals 2, while x left is, this is your y-axis. So x equals 0. So outer radius is 2 minus 0. So you square that. So this is r2 squared. Then minus, what is r1? It's from the axis going to the nearer end of the rectangle. So x right, anong x coordinate of this point? This is x equals square root of y. And then minus, x coordinate here is x equals 0. Okay, so we will have square root of y minus 0. Okay, squared. So, and then this is dy, right? Okay, so there you go. And again, find the volume, you will just get this. Okay. By the way, I remembered something. Remember, this is x equals square root of y. So maybe you're wondering why. But originally, the given is y equals x squared. Okay. So if we have y equals x squared, then how do you get the x coordinate here? Okay. So what you have to do is solve for x in terms of y. But from y equals x squared, you will have x equals plus minus square root of y. Okay? So plus minus square root of y actually pertains to two parts of the parabola. Positive square root of y pertains to the right branch of the parabola, while negative square root of y pertains to the left branch of the parabola. So you just have to check which one is relevant to your plane region. In this case, the plane region only uses the right branch, so that's why this is x equals positive square root of y. Okay, so that's just a little detail there that you might not have gotten. So anyway, this is the final answer. Okay, so another example but different region. Okay, so the line is x equals 4, so it's a vertical line here. And notice that we have two parabolas, and both are horizontal parabolas. So question is, how do you identify which one is which? How do you know if a horizontal parabola is opening to the right or to the left? So if you don't remember, all you have to check is the coefficient of y squared. If the coefficient of y squared is positive, then it's opening to the right. If negative, then opening to the left. So x equals 3y squared opens to the right, so it's the green parabola, while the other one, 4 minus y squared, is the blue parabola, which opens to the left. Okay, so that's how you identify the curves. So let's find the volume using, again, the method of discs or washers. So again, since vertical yung axis, then horizontal naman yung rectangles. And do we get washers or discs? It's washers because, again, walang segment that coincides with your axis of revolution. And do you use x or y? Since horizontal, we use the variable y. Okay. Use washers and use the variable y. So this is from y equals -1 until y equals 1. Okay? And then we have what? Outer radius is from axis going to the farther end of your rectangle. So this is horizontal distance. So x right is x equals 4 minus x left, that is green parabola, is 3y squared. So it's 4 minus 3y squared. That's the outer radius. And then square that. And then minus. So next is inner radius. It's from axis going to this nearer end of the rectangle. So what is that? X right will be x equals 4. X left will be, this time is, this is your blue graph. So this is your 4 minus y squared. So you will have 4 minus y squared. Make sure there's a parenthesis because you're subtracting the sum. Okay, so this entire block, this is your R1. So you square that. Make sure you have brackets. Okay, and then make sure that pi, you have a parenthesis for R2 squared minus R1 squared. Okay, and then use dy, and then this is from y equals -1 until 1. And that's how you set up. By the way, it says set up, so there's no need to answer this further. And this is already your final answer. No need to simplify anything. This is fine the way it is. Okay? Okay. So some tips to summarize discs and washers. Just remember this formula. And then if vertical rectangles are used, use the variable x. If horizontal rectangles, then use the variable y to set up R1 and R2. If vertical rectangle, then use vertical distance. Horizontal rectangle, use horizontal distance. We've already covered that before. And make sure that your radius is measured from the axis, okay, whether the outer or inner radius. So, meaning the radius should look something like this. So it's a function, so if it's in the variable x, it should be a function of x minus the axis a, okay, or a, the axis a minus a function of x. It should look something like that all the time, okay, for the outer and the inner radius. Okay, next, the disk is actually just a special case of washers, okay, where the inner radius is 0. So can you imagine that? So remember, if the inner radius is 0, then that means that you don't have a hole. So walang butas. Kung walang butas, then you will just get a disk. So that's it. And what's the point? That means all you need to remember is this formula. Because anyway, the disk is just the case where inner radius is 0. So just remember formula for washers and you're good to go. And in general, the inner and outer radius should hold for the entire interval. Okay? Otherwise, you need to subdivide the region the way you do for areas. Remember, sometimes you have to split the integrals. So this can also happen for volumes. So let's show that using this example. So notice that here's our plane region and may kulang na information. Wala yung points of intersection so far. So you must provide that if they are missing. Okay? And how do you do that? You just have to solve the system of equations per pair of boundary curves. So for example, here, you just, solve the system of equations for 3x plus 2 and x squared minus 2 here. You will have two possible points, but you have to eliminate the unlikely one, which is 4, 14, because diba dapat nasa third quadrant, so it must be, must be -1, -1. So you should get this one, okay? And then for the rest, you will have these, okay? So let's go to the actual problem. So our axis of revolution is y equals -3. Is that a horizontal or vertical line? It is horizontal, okay? So meaning our rectangle must be vertical. Okay? So if it's vertical, then what variable? It should be x. Okay? And do we have washers or discs? We have washers. Okay? Because, yeah, walang segment that coincides with your axis of revolution. So use washers and use x. And what is our interval? Oh, it is from x equals -1 until x equals 2. But wait, okay? Notice that the boundary curves above is not always the same, okay? So sometimes it's 3x plus 2, but sometimes it's -3x plus 8. So what does that mean? So just like our last remark, it just means that, okay, we must subdivide the region. Okay, so where will we split the region? Okay, so we must split it at the x value where the boundaries change. Okay, which is at x equals 1. Okay, at x equals 1. So that means we will have two subregions. The first is from x equals -1 until x equals 1. Then the next will be from x equals 1 until x equals 2. Okay? And then the volume of the solid will just be the sum of the volume of the first subregion plus volume of second subregion. So we will have two integrals. Okay? So yung first one is from -1 to 1, and then the second will be from +1 to 2. Okay? So let's set up first the volume for the first subregion from -1 until 1. So we will use washers, right? So by the formula, we must have the outer radius. Okay? What is the outer radius? This is vertical distance. So y up minus y down, where y up is farther end of rectangle, so 3x plus 2, minus y down is the axis, so it's plus 3. Okay? So minus -3 is plus 3. So this is outer radius square. There you go. And then minus inner radius is from here until here. So inner radius is x squared minus 2 minus -3. Okay? Or plus 3. And then square that. Then you have dx, and this is from -1 to 1. Then plus, so next is the region from +1 until 2. Okay? So the second subregion. So in this case, our outer radius will change because iba na yung upper function here. So y up will be -3x plus 8. Okay? Minus -3. So that will be our outer radius squared. Minus inner radius will still be the same because notice that this still belongs to x squared minus 2. So therefore, this is x squared minus 2 plus 3 squared. So dx, and this is from x equals 1 to x equals 2. And that's how you set up the volume for this example. So notice that there is a split in the integral because yung boundaries are not consistent sa taas. So in other words, iba yung nagbago yung y up. So kung magbabago yung y up, y down, x right, or x left, then so y up or y down for vertical and x right, x left for horizontal, then that's the time that you should, subdivide the region or split the integral. Okay. And that's it for this first video. I hope to see you in the second video about volumes by slicing. Bye!